Why is Brønsted-Lowry important for chemistry? Imagine you're watching a magic trick where one person hands over a ball and another catches it. In chemistry, acids and bases do something similar with tiny particles called protons. But understanding how they do this is more than just magic. It's science that explains many everyday reactions. That's where the Brønsted-Lowry theory comes in. It helps us understand acids and bases in a simple yet powerful way. This theory is important because it focuses on the transfer of protons, which are hydrogen ions. An acid is any substance that can give away a proton, and a base is any that can accept one. Think of it like a game of catch where the proton is the ball being passed back and forth. This idea makes it easier to see how acids and bases behave in different situations, not just in water but in all kinds of environments. Before this theory, scientists thought acids and bases only worked in water. But Brønsted-Lowry expanded that idea. Now we know that acids and bases always come in pairs, called conjugate pairs. For example, when hydrochloric acid releases a proton, it becomes chloride ion. When ammonia accepts a proton, it turns into ammonium ion. This pairing helps chemists predict what will happen in reactions. It also explains why some acids are stronger than others based on how easily they give away protons. The theory is especially useful in organic chemistry and biology. Many reactions inside living organisms involve proton transfers, even if they don't happen in water. For example, enzymes that help digest food work by transferring protons. Many medicines contain nitrogen atoms that act as bases, accepting protons to become more soluble in water. This makes drugs easier to absorb and more effective. In industry and the environment, Brønsted-Lowry helps us design better catalysts that speed up reactions. It also helps us understand how soil and ocean acidity affect ecosystems. In food science, it guides fermentation and preservation methods. In laboratories, it is essential for titrations and preparing buffers to keep pH levels steady. Overall, this theory connects many everyday phenomena to the fundamental behavior of acids and bases. It shows us how proton transfer influences digestion, cleaning, medicine, and even the environment. Understanding this concept helps us see the science behind the world around us in a simple, clear way.